Black elk is, I think red elk was named after Black Elk, who's an important Indian leader. That's all I can tell you. He drops from a cliff, strikes the water at a velocity of 34 meters per second, right? Now, I'm going to trust that that velocity is actually negative 34 because it's going down, right? Okay. You've got to put those minus signs on there, though. The textbook is not going to do that. So let's draw a picture. Here's Black Elk, very obliging cliff, right? He's up here to begin with, right? And he strikes the water, right? He's moving downward. His velocity, his final velocity, is negative 34.0 meters per second. And that's because he's going down, right? All right. So let's go from the top to the water. Let's go X, VI, VF, A, and T. Okay, so X, I guess we don't know X. Initial velocity, he drops. So I'm going to say that the initial velocity is 0. Okay. Final velocity is negative 34 meters per second. And then the acceleration is negative 9.8 meters per second. Okay, so this is the power tip, right? The fact that that's negative 34 and not the positive that you're given, that's another power tip. That he starts off at a 0 velocity is something you have to infer from the problem. Okay, time. I think we can find time. We can use no x, so let's find the time. All right, I'm going to use this guy. VF is VI plus AT. So final velocity is minus 34, is 0 plus negative 9.8 times t. Okay, so I think that ends up being just 34 divided by 9.8. 3.469. So the time is 3.469. Then it would round to like 4694. It's like 38 or something like that seconds, right? So time to hit the water, 3.47 seconds. 3.47 seconds. That's good enough, right? Okay. And then how high is the cliff? I could use this time, but what I'm going to do is I'm going to use no t. Okay, so to find the x, I'm going to use this guy. I know it's working a little extra hard, but I can do this without using that time, and I like that better. Because if I got the time wrong, I'd also get this wrong, right? And we'd crash our rocket ship or something like that. Okay, so final velocity is minus 34. I'm warning you, you got to put the parentheses or your TI calculators will evaluate that as a negative number, even if you use that little unary minus. Okay, so that equals 0 squared plus 2 times negative 9.8 times x. Okay, so 34 squared is 1156. 0 squared is nothing, right? And then this is negative 19.6x. I'm almost there. Oh, interesting. I'm going to get a negative number, but that makes sense, right? Okay, so the next thing is I'm going to divide by 19.6, negative 19.6. So this number divided by negative 19.6 is negative 58. .979 meters. Okay. Now here's the crazy thing. If I write 3 digits, I have to write 59.0 meters negative, right? You could just write this. I mean, I just honestly don't really care that much. I mean, don't write 17 digits or something like that, right? Now, how high is the cliff? Well, what we just figured out was that his displacement from here to here, we figured out that this was x is negative 59. Now all that means is that he goes down 59 meters to hit the water, okay? But it would be weird to say that the cliff, well, how high is the cliff? Well, from the top, you go down 59 to get to the water, right? You just say that the cliff is 59 meters tall, okay? So now that's a fine point, right? If you just write negative 58.979, I'm not going to take off any point. I might points or something like that. But I might say something sarcastic, because that's kind of a weird way to say the height of the cliff, right? But you understand why we got that negative number, and that's because we're figuring out the displacement from the top to the bottom. And to go from the top to the bottom, you have to go down. Okay, there you go. The next two problems are just whiteboard problems. See if you can work them out. If you can't work them out, look at the video.